So the topic for today's class is recover from Namenode failure. So we'll be starting the class with the agenda. Agenda for today's class is what is Namenode, responsibility of Namenode, single point of failure, causes of Namenode failure, Namenode recovery, role of secondary Namenode, FS image and edits file, checkpoints in HADOOP, creating checkpoints, and recovery with the help of checkpoint. So this is the agenda for today. We'll be exploring these things in more detail one by one. So let us start with the first one, that is what is Namenode. So we know that Namenode is the master machine of our system, and we also know that that is the single system in our Hadoop cluster. So if that is down, then what are the different steps to recover our Namenode? So those things we'll be covering in today's class. So Namenode is a service, or you can say a process, which runs on master machine of Hadoop cluster. We need to contact Namenode for any read or write operation in HDFS. We know that Namenode neither participate in storage nor participate in processing. Our data is distributed among slave machines, and our slave machines only participate in the processing of our data. But still we need to go through Namenode only. As a user, we cannot interact directly with your slave machines. We have to interact with only the Namenode, and after that Namenode's duty is to interact with slave machines. So that's why we have a lot of dependency on Namenode. So Namenode keeps metadata of the data which is stored in HDFS. As I just explained you, that Namenode does not participate in the storage. Whatever user data, whatever data you are copying into HDFS, that is stored in slave machines only. But all the required details about that data, required details means the name of the file, size of the file, owner of the file, how many blocks your file has been split into, and where exactly those blocks are stored on which machine. These information are known as metadata, and metadata is stored on our name. So before we read any file, or before we write any new file, we need to interact with name. So apart from keeping the metadata of all the files, Namenode coordinates with data node to read-write data in HDFS. So whether it is a read request or it is a write request, it goes through Namenode only. We cannot directly contact data node for reading or writing the data. So this is a very brief about Namenode. Now we are moving to the next slide. The next is responsibility of a Namenode. As this is a master machine, it has to do a lot of things. So let's check it out. What are the different activities our Namenode is performing in our Hadoop cluster? The first one is Namenode keeps a block map of all the files in HDFS. Block map means which block is stored on which data node. And along with that, if your block is replicated, maybe the replication factor is 3, it means that the particular block is stored on 3 different machines. So every information is kept with Namenode, and that information is known as block map. It contacts each data node and asks for block report. When we are starting our cluster by typing start all.sh, your Namenode is getting started as well as your data nodes are also getting started. And in the meantime, your Namenode will contact each data node and ask for block report. Block report means what are the different blocks which are available on that particular data. So one data node, you can say one slave machine, is not bothered about any other slave machine. It is only, it can tell what blocks are stored in that machine. So ultimately every data node, every slave machine will be sending its block reports to the name node. And name node creates bigger block record from all the data nodes block. Whatever details it has received from different slave machines, it club all those details to create the bigger block. Apart from maintaining this metadata and the block map, it keeps list of live nodes and dead nodes. Yes, that's also required. Because as a user, when we are doing a read request or when we are doing a write request, your name node is redirecting that request to particular data node. But before the name node is sending any request to any data node, it must know whether that particular machine is live or dead. Suppose I am sending a read request. I want to display the content of a file over the terminal. So I will execute the command /hadoop fs-cat and the file path. But somehow the machine which contains this file data, that is down. So if name node does not know that, it may be redirecting the request to that particular data node, and you know that the machine is down and we will not be able to access our data. So this is very, you can say, not a good thing. Name node should know in advance whether that particular machine is live or dead. If that is dead, in that scenario, name node should not redirect the request to that particular machine. It can redirect the machine to some alternate machine which contains the another copy of our similar data. So this is possible only when name node has the list of live nodes and dead nodes. It balances the storage of Hadoop cluster. As discussed in the yesterday's class, balancing of your HDFS is also name node's duty. When you are adding new machine to the cluster, or if you are removing old machine from the cluster, in that scenario, your data needs to be moved properly so that your complete HDFS is balanced. There, it should not be like that one machine is overloaded with the data and another machine is underutilized. This should not be the case. Every machine should participate in the storage and no machine should be overloaded. And that is possible only when your name node will balance your Hadoop cluster by moving the data from heavily loaded machine to underutilized machine. So these are the different responsibilities of a name node. So we can move to the next slide now. So now we know that there are a lot of responsibilities which name node has to handle. But if that is down, because that is a single machine, we are having only one name node in our Hadoop cluster. If that is down, then that's not a good thing for our cluster. So name node is a single point of failure in Hadoop cluster. Single point of failure means if that is down, then complete Hadoop cluster is not usable, not accessible. So Hadoop cluster is not accessible if the name node is down. We can't do any read-write operation even data nodes have all the data. As we discussed on the first slide, that your data is available on data nodes and even the data is processed from data nodes. But still, we can't access that because our intermediator, that is name node, through which we can read or write our data, that service, or you can say that machine, is done. Port backup is not yet supported in Hadoop. We know that apart from slave machine and master machine, we have a backup machine as well. That is a secondary name. So if name node is down, why can't we take help from secondary node? Yes, we will take help, but helping is a different thing, and immediately taking care of the responsibility is a quite different thing. So your secondary name node is not the hot backup of node. Hot backup means the the main server and the backup server are fully capable of handling the request. It means that if name node is down, secondary name node should work as a name, but it is not a hot backup. Hot backup means it can work just like your main server, and cold backup means it can only help you to recover that. So secondary name node is the cold backup in Hadoop. If name node is down, your Hadoop cluster will be offline for some time. You will not be able to read the data, write the data, or execute any MapReduce job. But with the help of secondary name node, we can recover our name node, and again our Hadoop cluster will be ready. So this is about single point of failure. Moving to the next slide. This is about causes of name node failure. When we are saying that our name node is getting failed or name node is down, what exactly does that mean? So there may be two reasons behind you can say name node failure, either the hardware issue or the software issue. So let's check it out. Master machine can stop working due to hardware problem. Yes, that's absolutely right. If somehow due to power failure or due to any other hardware issue, if your machine itself is down, in that scenario your data node will not be able to, you can say, receive some instruction from the master machine, and without receiving the instruction, your name node does not do anything. Name node metadata can get corrupt. This is another reason behind name node failure. So either your machine is down or your name node process is not running. Both are two different things. And the most common scenario is your machine is running fine. The only thing is when you are doing JPS in your terminal, you are able to see all the processes except name. It means that you started your Hadoop, you opened the terminal and you typed JPS. That should display name node, data node, job tracker, task tracker, and secondary name. But unfortunately, the name node process is not displayed. It means that hardware is fine, system is running fine, but somehow your name node service is not running. And the most common reason behind that is shutting down the system without stopping Hadoop. Because as per the standard rules, we need to stop our Hadoop before we shut down our system. But sometimes suppose we have shut down our system without stopping the Hadoop, there are a lot of chances that the next time you will start your Hadoop, your name node might not be available in your JPS list. The reason being is when you shut down your system, your Hadoop may be doing some activity, maybe reading some data, writing some data, or executing some MapReduce job. So in that scenario, if you are shutting down the system, suddenly your process will be killed. Killing the process and stopping the process are two different things. So standard procedure is to stop the process, but when you shut down the system without stopping, it will immediately kill all the Hadoop processes. So if some file is in between, or you can say your name node metadata that contains all the information about all the files, that might get corrupt, and that is the reason of not running of your name node service. The next time you will do start all.sh, it will not start the name node service. That is the most common reason behind name node failure. So after that, without metadata, name node is not capable of finding the data in HDFS. Yeah, that's absolutely right. If your name node is not running, and if you will try to do cat command /hadoop fs-cat and the file path, you actually want to display the content of a text file, but we don't know which data node contains our file. So we need to find this information from name node, but we know that name node is not known. It means that even if your data is available, you can't access your data because there is no one to tell us where exactly our data is located, on which data. So we cannot contact data node directly for data because we don't know which machine contains our data. Checkpoint can be used to recover metadata. So checkpoint are just like restore point in Windows. In Windows, we can create restore point whenever we think that our system is running fine. And in the future, when our system is getting some issue or our setting might get corrupt, in that scenario, we can restore our system back to the restore point. Similarly, in Hadoop, we can create checkpoints at some particular point of time, so that in future, if you think that something is wrong, our name node is down, we can recover our name node with the help of those checkpoints. So how to create the checkpoint, how the checkpoints are useful for recovery, and how to recover the name node with the help of checkpoints. These things will be covering in the coming slides. So we are proceeding to the next slide. The next is name node recovery. So name node must be recovered in order to access HDFS. Yes, absolutely right. Once your name node is not coming in your JPS list, after that, until or unless you will not recover the name node, it will not start automatically. You have to take some decision, you have to take some steps to recover that. So Hadoop cluster will remain offline until we recover our name node. Any user in your team will not be able to do any activity until we recover our name. So secondary name node can help name node to recover. Now the role of secondary name node comes into the picture. We can only recover till the last checkpoint saved. What does that mean? It means that suppose I created a checkpoint at 11 a.m. It means that at 11 a.m. I created one copy, one backup of name node metadata. Checkpoint is nothing but backup of metadata only. So suppose I created a checkpoint at 11 a.m. and after that you added more files, you deleted more files, you might have executed some MapReduce job. You have done a lot of activities. So from 11 to 11:30, you might have done a lot of changes in your HDFS data. And suppose at 11:30, your name node crashed. Now, you may be thinking that we are having the checkpoint and we can recover our name node. Yes, we can recover that, but we can't recover till 11:30. We can only recover till the last checkpoint shift. We created a checkpoint at 11, so we can recover till 11 a.m. only. Whatever data or whatever changes you have made after 11 to 11:30, those will not be recovered. Okay, so you can say that we have some limitation on recovery. But if I am saying that I can't recover anything, that's very bad thing. Instead of that, if I am saying that I can't recover 100%, but I can recover at least 90 to 95%. I think that's far better than that. So stale data is far better than no data. We know that the data which we will be recovering, that is not up to date. That is stale data. But I think stale data is far better than no data. And if we can't recover anything, that's not a good thing. Whatever we can recover, that is better than not recovering anything. So before we proceed, we have a request from Siva. Let me show you that thing. He's asking that what is the default time for sending a signal. So let me check it out and how to modify that. So we'll be going to local cluster home. We'll be going to my Hadoop. We'll be going to source. And then let's start from HDFS default.xml. We'll search it out in this one. If we will not find the property in this one, then we will search in some other default file. So let me search. Okay, you can see this one, dfs.heartbeat.interval, that is 3 seconds. Determines data node heartbeat interval in seconds. Every after 3 seconds, data node is sending the signal message, or you can say heartbeat, to the master machine. And with the help of this heartbeat only, your name node maintains the list of which machine is live and which machine is dead. So this is default time, that is 3 seconds, not the 2 minutes. In case you want to modify this, simply copy this property, and as we are copying this property from hdfs default.xml file, we will paste this property in hdfs site.xml file, and then you can change this value. You may be interested to make it 30 seconds or 60 seconds or 120 seconds as per your requirement. So this is the property which is telling you what is the default time for sending the signal message, or you can say heart. So coming back to the PDF now. So we are moving to the next slide. The next is role of secondary name. So secondary name node must be on separate machine in Hadoop production cluster. Right now, if you are doing JPS, name node, data node, secondary name node, all the processes are running on your system. For learning purpose, it's fine. But in actual production cluster, we are not running the secondary name node on the same machine. The reason being is the checkpoints, that is nothing but the backup of your metadata. Checkpoints are actually stored on your secondary name. It means that if secondary name node is running on your primary name node machine only, then you can say that actual data, actual metadata, and the backup of metadata both are stored on the same machine. And suppose somehow your machine physically down, then what will you do? Even your backup is not available, and without that you will not be able to recover your name. So in production environment, your secondary name node should be always running on a separate machine, so that even if your name node is physically down, we should have the backup of metadata available on some other machine, with the help of which we can recover our name. So by default, the secondary name node runs on the same machine on which name node is running. But we can change the settings and we can run it on a separate machine as well. So this is the setting. Add the following entry in hdfs site.xml to run secondary name node on another machine. So the name of the property is dfs.secondary.http.address. By default, you will find 0.0.0.0:5090. So this way you can change that, remove the 4 times 0 and put the actual IP. So 192.168.1.2. This is just for example. You can put the actual IP of your secondary name node machine, and after that, once you will restart your Hadoop, your secondary name node process will be running on a separate machine. That is good for recovering the things. So checkpoints which are actually stored on secondary name node will help us in the name node recovery. So we'll explore these things in more detail in the coming slides. So let's move now. The next is fs image and edits file. So till now, whatever we have covered, that is something that we already knew, at least basic we knew, and we have covered in more in advance. But fs image and edits files are quite new things for us. We haven't covered these things earlier. So let's talk about this. FS image, that means file system image. At some particular point of time, I am taking the image of my file system. You can say that that is nothing but I am taking the backup of my metadata at some particular point of time. So FS image is nothing but my checkpoint only. So FS image contains snapshot of HDFS metadata at some particular point of time. Namenode loads FS image at its start. When you are starting your Namenode, then it is loading all the information from your FS image, because that contains all the information, all the metadata. So if that FS image is not corrupt, then it will load and everything will be running fine. But somehow, if your FS image is corrupt, then while starting your Hadoop, your Namenode will not be able to load it, and that's why your Namenode process will not start. So after every read or write operation, FS image is not updated. Yes, suppose at 11 AM, our FS image was ready, and after that you are making a lot of changes. You are reading the file, you are writing the file, you are processing some matrix job. So for every read or write operation, we are not updating the FS image. The reason being is, updating the FS image is a complex process. What we do is, we are recording all the changes in a separate file that is known as edits file. So I think this same concept is also used in databases as well. For everything, we are not making the changes in DB. We are collecting all the changes, and then in one go we made all the updation in, you can say, in bulk. That is a batch operation. Similarly, we are recording all the changes in an edits file, and later once we want to merge them, we can merge FS image and the edit file to create the new FS image. We can say that at 11 AM I had one FS image. From 11 AM till 12, in 1 hour, whatever changes which happened on my HDFS, those were captured in the edits file, and at sharp 12, after 1 hour, you can say, we merged old FS image and edits file to generate the new FS image. So this process keeps on running every after 1 hour by default. So let's proceed to the next slide. We'll explore in more detail. So these things will be exploring with the help of a diagram. So you can have a look at this diagram. This is the most important slide for today, because this will clarify the concept of creation of checkpoint. So let's check it out. We are having two machines. One is primary Namenode, the first one, or you can simply call it as Namenode, and another machine is my secondary Namenode. At some particular point of time, suppose we will take the same example, suppose 11 AM. At 11 AM, we have one edits file and we have one FS image file. So at this point of time, what we will do is, we will roll edits file. What's the meaning of rolling edits file? Because at 11 AM, we have old FS image that was actually created at 10 AM, and we have one edits file which contains all the changes between 10 AM and 11 AM. So at 11 AM, it's time to merge edit file and FS image file. We will do the merging, but before that, we will be rolling the edits file, because while you are doing the merging process, if some user is doing some read operation or write operation, who will be capturing those records? So before we merge those two things, we are rolling the edits file. Rolling means we are creating new edits file, edits.new. So this is my first step. So at 11 AM, I created one new edit file, and then the second step, retrieve FS image and edits from primary. Edits file and FS image file are being retrieved from primary name node to the secondary name node. The reason being is merging of these two things is a complex process, and we don't want to overload name node with all the things, because name node has some other responsibilities as well. So let's do this merging process on secondary name. So the third step, merge. Your secondary name node will be merging edits file and fs image file and create new fs image file. That is nothing but your checkpoint. fs image.ckpt, that is checkpoint. So you can see that every after 1 hour, the checkpoints are created at secondary name node. Or you can say that every after 1 hour, secondary name node is creating the backup of metadata that is stored on secondary name node. The fourth step is transfer checkpoints to primary. We have merged the two files, we have created the checkpoint, that's fine. But our primary name node is still using the old fs image, this one. It means that now it's time to replace the old one. So we will transfer the checkpoints to the primary machine and it will replace that. This new checkpoint, or you can say the new fs image, will replace the old one. So now at 11 AM, we have one updated fs image and one new edits file. The same process will happen from 11 to 12. All the records will be captured in the edits file, and at 12 the same process will happen again. The two files will be going to secondary name node, then will be merged together to create the new fs image. The new fs image will be coming back to our primary name node for replacement of old one. Now suppose that between 11 and 12, suppose at 11:30, at 11:30 somehow your name node crashed. What will we do now? Name node is down, that's fine. Name node metadata, that is fs image. The fs image which is stored on name node, that is corrupt due to any reason. But the fs image which is available on secondary name node, that is not being used. That is very safe. So with the help of checkpoint which is stored on secondary name node, we can recover our name. So this is all about fs image and edits file. The next is creating checkpoints. How the checkpoints are being created and how we can do that on demand. So checkpoints are taken every after 1 hour by default. You don't have to do anything. As I was giving you the example, 10 AM, 11 AM, then 12 PM, something like that. So every after 1 hour, the step is being repeated, and you can say the latest checkpoint is available every after 1 hour. And checkpoints are very useful for recovering from failure. But suppose you don't want to wait for 1 hour. Suppose from 11 AM to 11:30, you have made a lot of changes, and the next checkpoint will be created at 12 PM. And somehow the changes you are made are very critical, and you don't wait for the next half an hour. You want to create a checkpoint right now. So we have a special command for that. So the command is /HADOOP dfs admin -save namespace. N is the capital. So this is another dfs admin command. That's why we are using dfs admin. So this command will be can say creating the checkpoint at that particular point of time. But you can see that it's giving some error. It's saying that java.io.io exception safe mode should be turned on in order to create namespace image. This is some prerequisite for creating the checkpoint. So not an issue. We know that how to do that. So /HADOOP dfs admin -safe mode enter. Enter means we want to explicitly enter into the safe mode. Once you have entered into safe mode, you can again execute the same command, that is /HADOOP dfs admin -save namespace. That will be creating the checkpoint on demand. It has not given any message or it has not given any error. It means that it has successfully created the checkpoint. And after that, as we have explicitly entered into safe mode, so name node will not be coming out of safe mode automatically. we have to execute the leave command. So /hadoop dfs admin hyphen safe mode leave. This will be you can say forcing our name node to come out of safe. So by executing these commands, we can create the checkpoint at any point of time when you think that the situation is critical. Otherwise, by default, every after 1 hour, the checkpoints are automatically created. You don't have to worry about them. So proceeding to the next slide now. So we have created a checkpoint, but how do we verify that? We don't know where exactly we have created a checkpoint because we have just executed one command. So first of all, let's check where exactly the checkpoints are located on our system. So you can go to your secondary name node machine in case that's running on a separate machine, or if it's running on our local machine, then you can simply go to the folder structure of our local machine. I have just pasted the screenshot. So HDFS underscore metadata. This is a directory. You know that that is used for holding the metadata. You can go to that. Inside that you will find one subdirectory with the name current, another directory with the name image, and the third directory with the name previous.checkpoint. You can expand that, and inside that you will find fs image. This is nothing but the checkpoint. So you can go to this directory. You can verify whether fs image is available on this directory or not. And if that's available, it means that you have successfully created the checkpoint. So this previous.checkpoint you can see on the system, and this fs image file will be actually used for recovering our name node. So in the next slide we'll be talking about how to recover our name node with the help of this checkpoint. And previous checkpoint means it will only keep the latest checkpoint. At 11 AM you created one checkpoint, that's fine. At 12 PM you created one more checkpoint. So it will replace the older one, so that when we are recovering, we always find the latest checkpoint available, and we will be recovering with that. So this is the location of checkpoint. Coming to the next slide. The next is recovery with the help of checkpoint. So till now we know that what's the role of secondary name node, what's the role of checkpoint, how to create that, and where exactly your checkpoints are stored. Now it's time to recover them. So first of all, you have already started your Hadoop, and somehow your name node is not running. You verified the same by typing JPS, and name node process is missing. So the first step is stop Hadoop by running /stop all.sh command, because whatever are the other processes running, we need to stop them first. So that's quite simple. Second and the most important step is copy fs image file from checkpoint directory to current directory. Inside hdfs underscore metadata, we have previous checkpoint directory as well as we have current directory. Current directory contains that fs image that is being used by name, and previous checkpoint directory contains that fs image that is a backup that is not being used. So the fs image which is available in the current directory, that is corrupt. Just because of that, our name node is not running. So first of all, you can delete the fs image from the current directory of your hdfs underscore metadata. After that, we will copy the fs image from previous checkpoint directory, and we will be copying it to the current directory, so that your name node can use this backup of your metadata. So this is the simple step. And the third one, start Hadoop by running /start-all.sh command, because now our metadata is not corrupt. We have provided the another backup of the metadata that might not be up to date. You know that if your name node crashed at 11:30 and the fs image was created at 11, so that is not up to date, that we know, but at least whatever we can recover, 90% or 95%, I think that is far better than not recovering anything. So copy the fs image to the current directory and start your hoop, and hopefully your Namenode process will be running, and now when you will do JPS, your Namenode process will be appearing in your JPS list. So this is all about recovery of Namenode with the help of secondary name. So with this slide, we are done for today.